Video coverage of ITEXPO is brought to you by Content Boost, the content marketing specialists. Amplify your sales today.
So, welcome everybody to ITEXPO, the greatest business technology event ever. I'm very happy to be here and to spend the next half an hour with you talking about emerging technologies and how it is going to change the way we live. I have a slide about me, a book we already talked about. I am a chief technologist for innovation with Hewlett-Packard. Before that, I was a platform strategist with Intel and CTO of Emerging Technologies Group for TIPCO. I was also director of development at Symantec. And that is the picture of my book. I want to put a disclaimer here that all the views I express are entirely my own and not my employer's or anybody else's. So I want to spend this half an hour taking this exciting drive, talking about things that are not science fiction, but actually reality. I want to take wonderful examples, and I want to talk about some fun technologies that support them. But more importantly, I want this to be a snapshot of emerging technologies as of today. And the desire is we all get so fired up with all this that we go back, the nerd in us, the businessman, the businesswoman in us, goes and invents, starts more innovative solutions so that the next time we meet, this innovation, emerging technology would be already obsolete. I will take some examples out of Internet of Things, bots, and more importantly, how to secure them. And those are more like verticals, and so I'll talk about some horizontal technologies that have made it possible. Now, this is where I had a real problem because there are so many of them. But I just picked 4 as my favorite because I just couldn't talk for more than 30 minutes. But we can go endlessly. This is just a starter. I would like to talk about 3D printing, wireless power, see-through electronics, and self-healing materials. So let's talk about Internet of Things, how it is shaping and changing the way we live. One example is very recent from Google, the great innovation company, and they built contact lens for diabetics. Diabetics have always struggled because their longevity depends on how good their blood sugar control is, which in turn depends on how often we take the glucose reading and how often we act upon them when they are not normal. The contact lens here from Google can measure glucose level in tears, and it will take blood sugar level readings every second. Not only that, if the reading is not good, it will give an alarm through different small LED lights that light up. It also uses a very tiny wireless chip and sensors, which are very miniaturized glucose sensors. And it puts it in 2 layers of soft tissue that makes up the contact lens. And they're so small that they look like bits of glitter. And the antenna that is used for this is thinner than human hair. The big question here is, how do they power it? Where does the power come from for something that is sitting in our eyes? The good news is that the energy is pulled from the radio frequency waves from an external device. So that is the beauty of contact lenses that measure glucose from tears. Firefighters give up their lives to save other people's lives. And we are very concerned about their well-being when they go inside a building which is filled with smoke and fire. They lose sense of direction. They don't know, they may get lost. And therefore, it is important to have the latest technology. KTH Royal Institute of Technology at Sweden did exactly that. They built smart shoes that track firefighters. And what do? They use a digital positioning system inside the heels of the shoes. And they also have advanced sensors like gyroscope and accelerators. And they also have a processor right in the heel of the shoe. And this is very important for firefighters. It can withstand shock and extremely high temperature. And it can even work 25 meters below ground. This is the area where firefighters generally work. Number 3, this is about people who are motor impaired. People get hurt, either lose their ability or they lose their limbs. And living with artificial limbs is never as good as natural limbs. If you see, what is the missing point here? Normal people, when they want to move their hand or their feet, they just have to think about it. The brain sends the signal, the signal goes all the way to the limbs, and they act. That connection is missing. This brain gate innovation enables the limb movement. And what does it do? It converts the thought to action. How does it do that? It interprets and translates the brain signal in that chip that you see. And what does it do after that? It takes that signal and sends it to the gateway computer, which can then translate it to do different objects can be controlled in the environment, like television, computer, or even their own wheelchair or an artificial limb. And how does it work? It is a tiny sensor that is implanted in the cortex of the brain. And it is a device that analyzes the brain signal. That's amazing and extremely good news for people whose limbs have been hurt. So let's talk about bots. There are various kinds of bots, and I will take some scenarios where our lives have been changed. So one thing is our heart patients, those amongst us who are heart patients need pacemakers. It's a pain to implant them surgically. And the biggest barrier is the fact that pacemaker is implanted in the collarbone, and it is big. And there are wires that take from the collarbone, the LEDs that take them to the heart. It is a big device. They need a surgery to do all that. Medtronic has come up with a miniature pacemaker that is the size of a vitamin capsule. And the miniature devices don't require so much disruption to the body to be installed. And how do they work? They are so small that they can fit directly inside the heart. There are no leads that need to be installed in your body. And it is it can travel through the blood vessel. So it can be injected in your body and made to go through the blood vessel and sit right inside your heart. That's so neat for heart patients. Fertilization is another area where a lot of humanity struggles with. The natural process is for a sperm cell to find the egg. And it's that simple process. If it is out of whack, fertilization doesn't occur. So Dresden Institute of Integrated Nanosciences in Germany have come up with sperm bot. So it's a special kind of bot, sperm bot. How does it work? So the purpose of a sperm bot is it guides a living sperm cell towards an egg cell. And there are various things that are very neat about this technology. First thing it does is a sperm bot hijacks a sperm cell and then puts a tube around it and then basically turns it to a robot. Now, when it is a robot, it can be controlled. So a magnetic field is used to control it. The direction can be controlled, and the magnetic field will make sure they are directed towards the right direction. And the temperature is used to control their speed, how fast they move. The one thing that is very innovative about it is How does the sperm bot reach the egg cell without being powered? You have to think about it. They use flagella, which is body's internal motor mechanism. So, flagella is anyway used by sperms to transfer them, and the sperm bot also uses the flagella. So, that is really neat that sperm bots can help fertilize eggs. Let us talk about bacteria bots. Cancer, we know, is a deadly disease. Even when cures are available, chemotherapy is available, the side effects of chemotherapy are so high because your whole body is treated for cancer, which is not right, because the whole body does not have cancer. Only certain cells have cancer, and because of that, there are a lot of side effects of the current treatment. So, Cheonnam National Institute from South Korea have created bacteria bots that detect cancer cells, and they can treat cancer cell without the side effect of chemotherapy. How does it work? There is a certain bacteria, and that is a genetically modified, non-toxic Salmonella bacterium. So, what is good about this bacterium is that it is attracted to the chemicals that are released by cancer cell. So, we got a chemical which knows how to find cancer cells because it is attracted towards that. So, bacteria bot is a robot which uses that bacteria to sense the cancer, and then it moves towards the cancer cells and it attacks it by moving towards the exact tumor region. And therefore, because the treatment is so localized, we do not have the side effects of chemotherapy. So, that is how bacteria bots are used to treat cancer. So, there is another kind of walking biobots. So, they walk inside your body and they are biobots. That means that it is from University of Illinois, and these are called biobots because they are created from heart cells as well as hydrogel, and they are made by a 3D printer. By using a 3D printer, hydrogel and heart cells are used to create bacteria biobots that can walk inside your body and do various things. For example, if you want to do a drug screening chemical analysis, it can be programmed to look for that. Or if you are looking for a specific toxin, it can look for that in that environment. So, there are endless uses. So, that is about biobots that can walk on their own. There are bacteria bots, another kind of robots that detect cancer. How does that work? I apologize for using the wrong button. I was wondering. There is a forward and a backward. See, we need robots to do everything. Microbots deliver drugs. So, what is special about it? The Chinese university has built microbots, and the diagram that you see is of course an enlarged version. It is really a very small thing. What is the advantage of this microbot that is as small as a human cell? It can be used to direct drugs in a very non-invasive manner. It can deliver drugs very specifically, and it is like a cage-like device. You can see it looks like a cage. It is 40 microns long and 40 microns wide, 100 microns long and 40 microns wide. And so, the way treatment is done or the way the drug is delivered is, instead of doing any surgery or opening up your heart, microbots are injected into the body in between the vertebral columns, and then they are directed to the affected area in the brain. The good thing about all these robots is you can control them. Once you have it in your body, you can command them to do various things. So I talked about IoTs, Internet of Things, and bots. So it is extremely important to protect them. Let's talk about that. So we know bots, things can be converted to bots. So we take sperm, we convert them to sperm bot. We take bacteria, we convert them to bacteria bot. We take things and we convert them to bots. So bots, however, have a malicious purpose. Hackers can turn Internet of Things into bots. They are an army of infected devices. In January itself of this year, they were found that there were 750,000 phishing and spam. And it was found that they were originated from smart appliances, like 100,000 of them, like a fridge that you see. So refrigerator is an example of connected device. There are many other connected devices. They are poorly protected. In this particular case, they came with a password which was never changed. So the default password was used, and they were on the public network. The other thing was that connected appliances generally don't have anti-spam or antivirus software. So they are more prone. So what does it tell us? That we should design security as we design bots and bots and IoTs, Internet of Things. So it has to be the part of the design process. So this is an important part on how to secure Internet of Things as well as the bots that bring so much benefit to humanity. We talked about some verticals. I would like to talk about some horizontal fun technologies that support these. So let's look at that. So you can say, although to explain each of those horizontal, I have taken an example, but I want all of us here to start thinking about other ways. So you go back. This is a business technology event. This is ITEXPO. We are supposed to go back and take it to the next level and come back with the entirely different snapshot. So what we have here is how contour printers, concrete printers can print buildings. So we talked about 3D printers. Here we are talking about a very specific printer that can print buildings. Why is it so useful? So for example, military goes out somewhere in a dangerous place, and they have to live in camps or in some places that they makes them very vulnerable. So if we can, in a day, build them a building where they can be housed, it is amazing. It would change the way they protect our country. This contour crafting has created a device called 3D concrete printers, which does exactly that. And that picture that you see, it is a giant 3D printer, and it can be, build up to 2,500 square feet of building in one day. And what it does is, it is an oversized printer, no surprise about that. And it can follow a programmed schematic and lay down the building layer by layer. So what is it that a worker has to do? They have to put rails so that the outline of the building is defined. Once the bales are there, then the contour crafter controls it. It has a nozzle on a crane that deposits and sends out, spits out concrete. And that's how it is built. Amazing, isn't it? So another horizontal I want to talk about, BioPen. Now BioPen is like a concrete printer, a 3D printer, except there are some minor differences. We won't worry about it. But it is a pen because it looks like a pen. You can see that. And why is it a bio? Because it is used for biological, within the human, it is designed to work for inside the human body. And it is from University of Wollongong. How it can be used? Anytime a bone gets damaged or there is a cartilage injury from sports or motor vehicles, then surgeon can take a BioPen and draw on site the implant that has to be there. And how do they do it? They deliver cell material inside the bone that is broken, and it is extruded from the biopen like a 3D printer. And so, as the biopen is drawing it inside the body, then the body's natural regenerative action grows it into the exact space. So, see the beauty. You don't have to take molds and build it elsewhere, bring it back. You just do it right there inside the body using the pen. The other area that is of great intrigue to me is electric cars that can be powered wirelessly by the highways. I mean, that's what always made sense to me. Car runs on highways, and highways should be the one fueling them. Why do I have to go to the gas pump and put, I mean, it just doesn't make sense to me, right? And that's a problem they solve. So that is a picture of the wirelessly powered electric cars. So let's look more into it. It is a North Carolina State University. They designed the wireless power transfer. So how does it work? Wirelessly, the car can be powered when it goes through those highway stations. And the stations transmit power wirelessly. And the beauty of this is it requires a certain technology to transfer from a stationary source to a mobile receiver, which is the car in this case. Car has the receiver. The transmitter from the station broadcasts a low-level magnetic field. When the car is in range, it locks and starts transmitting energy. When the car goes out of range, it detects, and therefore it goes back to the normal level of and stops pumping out electric power. So that's how highway used electric cars will work, should work. Let's make it work. Seethrough Electronics has been one of my biggest answer to my wish list. I do not like the way we drive our cars. Half our mind is focused on seeing, am I out of gas? I am looking at, what is that engine light? Where is the navigation screen? It is only a fraction of time that we spend looking at those things. Why? Because the windshield is not able to give us that information. So these solutions will help us use transparent displays, which is the windshield of the car, to actually act as the navigation, act as the engine, or whatever engine status or anything else that we want. Now, that is just one application. There are many other applications of see-through electronics. This has come from University of Nebraska-Lincoln and Stanford University. And their transparent organic transistors that they have developed, what you see on the right, they use plastic instead of silicon. And plastic can be see-through easily. And these are organic transistors that are built, and they are high performance organic devices. So transparent substrate can be taken, and then electronics can be printed on that. That is how it works. What you see on the right is a transparent transistor, and it is the size of a postage stamp. It is not a transistor, but electronics that is printed on a postage stamp. So you see how wonderful that is. Another area that is exciting to me is how materials heal themselves. So there are many places where human life is at risk. Aeroplanes is one thing. When we sit on airplane, we sometimes can have a mechanical failure of a part, of a steel, of the body, anything. And scientifically, for the scientists, they have been not happy about it because things should not break. Why? Because they give us a lot of warning. A single crack never results in breakage. It's a set of crack accumulation, one after the other, that results in break of a material, of any material. So if we can see the first one and fix it, things won't break as often. Some things are very expensive to repair. Some things are life-threatening when they fail. Some others are just too expensive. And a lot of human life depends on it. So how do we solve that problem? So what I want to show you now is self-healing airplanes. MIT researchers have created a cracked metal, a metal that, if cracked, will heal itself. How does that work? The normal metals under tension, when you increase the tension, they fall apart. But a self-healing metal under tension does not come apart. Instead, it does the opposite thing. It goes back and fuses itself. And that's the amazing part. It doesn't break, comes back in place. How does that work? So what you see on the right is a self-healing material under, of course, zoomed into a microscopic level. And what it does is each metal has grain boundaries. And when you crack them, the grain boundaries give way, and the cracks stay there and accumulate over time. But in case of metals that are self-healing, when you stretch them out, then what happens? Grain boundaries shift. Because they are flexible, because they can shift, therefore, then it can heal itself. It doesn't break. And therefore, when the first crack is healed, the second crack, the third crack doesn't happen, because every crack is healed as they are formed. And this is very useful for airplanes, oil wells, as well as other hard-to-maintain components. So I want to close here by saying a few things. It is the best time of our life. We are in the best place of our life. All the nerds in us, like I said, the business people in us, we who can always want to innovate, push the boundaries, turn them into solutions that impact human beings. It's happening now. It has always happened, but it is the first time in the history when so many things are coming together, and we are in an avalanche of solutions. We saw some example of verticals that helped us. We saw some example of horizontal technologies. Like I said, it is my desire that as soon as you go out of this room, we figure out some more things, and by the time we meet again, we'll say, oh, it is so obsolete. What were you talking about? Thank you so much.
Thank you so much. When was that book signing once again? You want to give us some information on the book signing once again for the new people that came in?
Oh, yes. Very good. I would like to. In the exhibition hall, there are 11 books that ITEXPO has arranged. I will be doing the book signing for that. And I will individually sign and write a personal note for each one of you. That will be very relevant to you. And that will give me the chance to meet each and every one of you.
Thank you.
Thanks.
Video coverage of ITEXPO is brought to you by Content Boost, the content marketing specialists. Amplify your sales today.